Good day, everyone. We are now on the part 2 of the chapter 4, which is about matter, its composition, and organization. Now, in the part 1, as a recap, we have discussed about what is matter, its four states, such as, again, solid, liquid, gas, and the fourth one is we have plasma. We also discussed about the properties of matter. We have physical properties and chemical properties. And also in the part 1, we have discussed about the changes of matter. It could be a physical change or a chemical change. Now, as a continuation of the discussion about matter, in this chapter, we will be discussing about the classification of matter. Now, matter can be classified into two. So we have pure substance and we have mixture. Pure substance has two types, such as elements and compounds, wherein compounds can be organic compounds or inorganic compounds. As to mixture, naa siya'y duha ka types. We have homogeneous and we have heterogeneous mixtures. For homogeneous mixture, we have solution. And for heterogeneous mixture, it could be a colloid or suspension. Now, let us elaborate or discuss further about this classification of matter and its types. Let's start with pure substance. Now, in this figure or picture, as you can see, these are example of pure substances. So we have a gold metal or gold, salt, copper, hydrogen gas, diamond, and then we have sugar. Now, these are examples of pure substances because they are composed of only one type of particle or their composition is constant as well as their properties. So meaning dili ma-change ilahang composition all throughout the sample. And also we can observe their characteristic. So without changing or altering the identity of the substance. Now, what are again the kinds or types of pure substance? So let's start with the first one. We have the elements. So these elements are not new to you because in your chemistry classes, in your junior high school and senior high school, you are already introduced about the periodic table of elements, right? Now, what are elements? Elements are substance or substances that cannot be broken down into simpler substance by a chemical change. Since belong siya sa pure substance, dili siya pwede ma-broken down into kuan pa, tawag ani another substance or simpler one. Now, in the periodic table, as you can see here, it is divided or classified into three. So this part, this, and then kanisha are what we call metals. And in this part, these are what we call non-metals, including C, hydrogen. And this one are what we called as metalloids. They are called metalloids because they have properties just like that of a metal, and also they have properties just like that of non-metal. Now, in the periodic table of elements, there are 118 elements, starting with the hydrogen and then ending with or organism as the 118th element. Now, if you're going to observe the periodic table of elements, their names or some of the names of the elements coming from a famous scientist. So let's give example. So we have ES, or this is what they called Einsteinium. So from Albert Einstein or Einsteinium. And then another one is from countries. So example nato is we have Californium. So Californium from the country that is California. So we have here. And then another one from the CF is for a state which is under a country. So example of that is we have America, or this element americium. And aside from countries, states, and famous scientists, some also are named by the planets. So we have this one, Pu, for Pluto or plutonium. And also, or some elements are named by Greek words. Example nato is we have chlorine. So chlorine comes from the Greek word chloros, which means greenish yellow. And some elements are named by Latin words. Example, we have Au. So this Au means aurum, which is a Latin word meaning shiny. So, but this symbol EU is an element that is gold. And also, some elements are named through minerals. So we have example magnesium from magnesia. So aside from their names, they are also expressed into chemical symbols. As you can see, some are expressed in the E letter, and some are, or mostly are expressed or written into two letters. And aside from that, in the periodic table, there are new elements that are identified, so such as this nihonium, we have moscovium, we have tennessine, and the last one we have oganison. So those are some of the characteristics or naa sa periodic table of elements. So all of these are pure substance. Next, aside from elements, the second type of pure substance, we have compounds. Now, compounds are substances formed when two or more different kinds of atoms or elements are combined or chemically bonded together. So, as we discussed here, elements, so pag, for example, si chlorine ni combine with Na, so we have NaCl. So that is salt. So pag mag-combine na sila, NaCl, we are forming not an element but a compound. So let us explore what are the types of compounds. So first one is we have organic compound. So organic compound are those contains carbon and hydrogen at the same time, called as hydrocarbons or series of carbon atoms, or organic compounds consist of carbon atoms. So what are examples? Methane. So as you can see here, composes of two elements, right? We have C for carbon and H for hydrogen. And other one is we have glucose. As we know that glucose is the product of photosynthesis. So we have C6H12O6. So naa siya carbon nga atom. And then also hydrogen, and we have oxygen. The other type of compound is we have inorganic compound. So this time, it is a compound that doesn't contain carbon and hydrogen, unlike sa organic compound. At the same time, or not at all, such as carbon dioxide. It may have carbon, but there's no hydrogen. So what are examples? The hydrogen oxide, so wala siya'y carbon. And then we have sodium chloride as our example a while ago. So NaCl, Na is an element, Cl is another element. That makes it a compound. Now, examples of these organic and inorganic compounds, aside from these examples, so we have, for organic compounds, examples are carbohydrates. As we mentioned about glucose. Glucose are example of sugar, which is, ang carbohydrates are sugar. We also have proteins, fats or lipids. And for inorganic, examples we have salts, which is the NaCl. We have water, H2O, and then we have the oxygen or water, which is a combination of hydrogen and oxygen. That makes it an example of inorganic compound. Now, let us proceed with the other type of or classification of matter. So the second one is we have mixtures. Now, as you can see here in the figure, there are two substances wherein they are mixed together. So from the word mix, so gisagol sila. So you combined them. So therefore, when you talk about mixtures, it is a combinations of two or more substances that can be separated by physical methods. They have variable compositions. So if ang pure substance, isa ra gyud iyahang composition or material or particle niya. While sa mixtures, combinations of duha or more than substances. Now, what are the types of mixtures? Let's start with the first one. We have, again, homogeneous mixtures. Now, if we talk about homogeneous mixtures, from the word homo, so meaning, homo is one or uniform ang iyahang composition and properties as we see it with our naked eye. So kaning nga mga mixtures, if ato ang lantawon, mura siya og pure substance because uniform, parihas iyahang composition. But take note, they are mixtures. So combination natay gi-combine. So what are examples of homogeneous mixtures? Or to specifically give type of homogeneous mixture, we have this solution. Now take note, in a solution, naatay duha ka composition, right? If you can remember, a solution has a solvent and a solute. Pag mingon ta og solvent, mo na siya ang mo-dissolve. Pag mingon ta og solute, mo na siya ang i-dissolve. Example nato is we have when you are making a juice. So your juice powder serve as your solute. Mo man to'y tunawon ang juice powder. Ang imuhang water will serve as your solvent. Mo to siya ang mo-dissolve or mo-tunaw sa imuhang juice powder. Now, in here, these are example. So we have ang duhang ato ang i-mix, we have gas in gas. So the same sila, gas o another gas. So example nato is air. Take note, our air or the air composes of different gases. Hydrogen, unsa pa diha nga mga compositions sa atong earth, nitrogen. Next, we have gas in liquid. So gas in liquid, example nato is carbonated beverages. So, di ba we have Coke? Ang Coke, di ba when you open it, there is a sound because of the carbon gas. And we have liquid in gas, vapor in the air. So, liquid in liquid, for example, alcohol. So, 70% ethyl alcohol. So, aside from kuan, na siya mga composition. Pero if you're going to look at alcohol, di ba, mura siya og isa lang, mura siya pure substance. Wala kay makita nga lahi nga kuan niya composition. But take note, it is a combination of two liquids. Another one is a liquid in solid. So we have dental amalgam, and then we have solid in liquid, salt in water. Then we have solid to solid or alloys, or there are what we call metals. So those are examples of a solution which is under into a homogeneous mixtures. Take note, homogeneous mixtures, it can be seen as uniform in terms of composition and properties, but take note, they are made up of two or more substances. Let's proceed with other types of mixtures. So we have heterogeneous mixtures. So heterogeneous mixtures, we have colloids and suspension. Now, what is the difference between the two? Colloids is a mixture with particles bigger than that of a solution but smaller than that of a suspension. So, there is siya nga part na natay mga makita nga mga particles unlike sa homogeneous, but again, naapay mas bigger nga particles nga makita nato nga types of heterogeneous, and that is suspension. Now, these colloids can pass through filters or pwede sila masala ang mga particles. So the word colloid came from the Greek word kolla, which means glue-like. So ang colloids, na siya mga properties. So properties are, first we have turbidity. Turbidity means the cloudy and muddy feature of the system. If you look at an example of a colloid, ma-observe ni mo nga mura siya og cloudy or muddy, dili siya clear because of the particles. And then another one is viscosity. Viscosity is the mixture's resistance to flow. And we have Brownian movement in honor to Robert Brown nga siya ang naka-introduce or naka-observe ani. So this is the rapid and hazard motion of the particle or rapid paspas ilahang movement, which is the reason why colloidal particles do not settle. Dili sila mo settle or mo kuan mo pundo o kuan because they have a rapid motion. And the last property of colloids is we have this Tyndall effect. Again, in honor of John Tyndall, who discovered it in the course of his study into light beams, wherein Tyndall effect is the scattering of light in a colloidal solution. If you're going to use a flashlight or any light pointing into the example of a colloids, the light will scatter. So ang tawag ato nga pag-scatter sa light is what we call Tyndall effect. Now, for the suspension, sige, colloids again, na siya bigger nga particles than solution. But sa suspension, mas bigger iyahang particles nga mas makita gyud nato or ma-identify nato ang mga substances nga ato ang gimix. So where the suspended particles can be seen. So makita gyud nato with our naked eyes and are large enough to be trapped in a filter. After a while, the suspended particles settle at the bottom. So masuspend sila. Now, for the examples of colloids, so we have here type, colloidal particles, dispersion, medium. So kani ang mga colloid particles nato, in what state sila, kani ang ato ang i-mix or i-dissolve. Examples are here. So emulsion, example, liquid to liquid. Example is mayo or mga ginagamit nato, mayonnaise. And then others. Gel, so we have liquid to solid, gelatin. Aerosol, liquid to gas, fag. So, di ba pag mag-fag, especially in mga mountain areas or in MSU. And then we have solid and solid to gas. So, we have dust. And then foam. So, we have gas to liquid, whipped cream. Ginagamit nato sa tong mga salad. Gas to solid, styrofoam. So, styrofoam is an example. Sol, so we have solid to liquid, paints, mga pintal. Ang mga pintal is an example of colloids. So they are not totally liquid, 'di ba? Mura sila og sticky. In the next we have solid to solid, we have cement. So these are examples of heterogeneous mixtures, which is specifically examples of colloids. Next, for suspension, as we describe it, that mas larger iyahang size or mas bigger iyahang mga particles that we can observe it or identify the particles. So we have examples are the syrup or the in medicine, the syrup or mga ginainom sa mga bata. Wherein, nakabutang dito that, di ba, there is an instruction there that says, shake well before using because nakasuspend ang iyahang mga particles or composition. Another example is we have this halo-halo. So, this halo-halo, if you're going to look at it, there are many parts or iyahang mga ingredients. So, by just looking at it, you can identify as ang ice cream, mango, and then all, and others. So, these are example of suspension or heterogeneous mixtures. Now, the question is, can we separate mixtures since ang mixtures are combinations of two or more nga kuan substance? Can we differentiate or recover one substance to another after they are mixed? So there is a process that we can separate the mixtures. So what are those? So we have for heterogeneous mixtures, we can use decantation, filtration, flotation, centrifugation, and sedimentation. Sedimentation can be the same to flotation. For homogeneous mixtures, so we can separate them through simple distillation, fractional distillation, and we have crystallization and chromatography. So let's give illustrations or examples of these processes that we can use in separating a mixtures. Again, for the heterogeneous mixtures, we have decantation as one, and we have filtration. So as you can see in the figure, decantation, there is a pouring of a liquid from a mixture. So kaniyang ato ang mixtures, right? As you can see, naay tubig ug naay mga other particles here. Wherein, ato siyang i-pour into a separate container or liquid, or using the decantate or the process of decantate, wherein pag pour nimo diha, mabilin ang mga solid particles. So imuhang na segregate or na separate. So ang tawag ani nga setup is what we call decantation. Another one is we have filtration, or kung sa Bisaya pa, salaon. So in here, naatay we use funnel. So kani ang ato ang mixtures. So naay filter paper here or filter paper cone wherein mao na siya ang magsala sa mga solid particles. And then the water will be suspended here while diri mabilin ang mga particles. So by that, na-separate nato ang mixtures. Next, we have flotation and we have centrifugation. So from the word flotation, so we let the particles to float. So it is the removal of suspended particles either by sedimentation or coagulation. So makita nato diri that natay flotation column. So naay pressure nga ginakuan para katong mga suspended dere mo float sila, so ma-separate sila. Next, for centrifugation, it is the settling of tiny suspended particles using a centrifuge. So, naay, for example, in here, rapidly rotating ko ano siya, rotor. So, kani ang before niya, then after, masuspend dere ang mga solid particles, then ma-separate na dayon nato. So that is centrifugation. So again, for separating mixtures for heterogeneous, so we have, you can use decantation process, filtration, or flotation and centrifugation. Now, for the homogeneous mixtures, as again, we describe homogeneous mixtures are those that we can see by our naked eyes, uniform in composition and properties. We can use distillation. So natay duha ka types. We have, it could be in simple distillation or in fractional distillation. Now, what is the difference between these two? Pag mingon ta og simple distillation, the mixtures of two liquid, so the mixture of two liquids, kani siya, so the liquid nga naay lower nga temperature or boiling point, mo na siya ang muuna nga mo-boil. Pag boil niya, ang iyahang gas or ang smoke niya, papadulong dire, and then mo-condense siya. So from gas, mahimo siyang liquid, then mo na dayon ni ang distilled liquid. So na-separate na dayon nato siya. Again, simple distillation, kani ang mixture nato. Ang lower nga temperature nga liquid, maoy muuna nga mo boil. So pag boil niya, makaproduce na siya gas, tama? Which is a smoke. So padulong na siya diha, and then it will be situated here, wherein this is the distilled liquid. Another one is the fractional distillation setup, wherein kana siya is separating liquids that differ in boiling points by just few degrees. So katong mga mixtures or mga liquids nga differ in boiling points in just few degrees lang ilahang kalahian. For example, in here, 20 degrees, 70 degrees, 120 degrees, 180 degrees, 260 degrees, and so on. Now, example nato is, it is used in petroleum refineries. So, kani. So, this is an example of fractioning tower. So, na heater or na crude oil, makita nato kani sila ang mga mixtures nato or mga liquids. So, by that, ma-separate nato. Petroleum is separated in its useful parts such as fuel, oils, gasoline, o kana. So, ma-separate na dayon nato na siya. So, ang tawag ana is fractional distillation. And the two last process that we can use in separating mixture is we have crystallization and chromatography. For crystallization, it occurs when simple seawater is allowed to evaporate. Ato ang i-evaporate. Have you tried, for example, seawater, tapos imuhang i-boil, pakuluan nimo, and then when it boil, mawala na ang tubig, and then what? Unsay mabilin dayon makita nimo are crystals of salt. So that is example of crystallization. But in crystallization, this is not limited to liquid solutions. For example, gemstones like diamonds and emeralds form when molten rocks cool. So as you can see, we have here example. So a magma, so ani ang magma first ko nato, na siya composition A. So after pila ka cooling nato, nag-solidify siya. Example nato is igneous rocks. If ma-remember niyo sa Earth and Life, right? Igneous rocks are formed through the solidification of magma intrusively or extrusively. So, example to siya sa crystallization. Next nato is we have chromatography. Now, this chromatography is a solution can be separated by allowing it to flow a stationary substance. An example is an ink solution can be separated by passing the solution a piece of paper. The pigment travel at different speed through the paper. So example nato here, we have a color pen, and then as you can see, if atong i-shade nato siya sa piece of paper, makita nato ang iyahang color and then the differences. Kung slowly or different ang atong pag-shade. So kani siya is again the process in separating mixtures specifically for homogeneous mixtures. So those are the process again in separating homogeneous mixtures. We have simple distillation, fractional distillation, crystallization, and chromatography. So I think that's ends the discussion for this part 2 of the chapter 4. So if you have clarifications or questions, you can message me or you can come if you have vacant time in the office for consultation. And also, please like and subscribe this video. And thank you and God bless.